Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will start our next new section. The next section is that comber mechanics. Okay. So, here what we will be discussing basic function of comber and why the comber is used for hook removal of fiber, whatever hooks are present in the draw frame that we remove, and basically main function of comber is to eliminate the short fibers. So, the short fibers in comber is termed as knot. It is not waste basically, we do not normally call it as a comber waste, it is a comber knot, because this knot it is a very good clean fibers and that can be used for different applications. And comber knot theory we will be discussing here, and knot theory actually depends on both forward feeding and backward feeding. So, we have two types of feeding system I will mention, and what is the difference between the short staple spinning, in the short staple spinning that for cotton. So, we use short staple comber, and for wool which are long fiber. So, the comber is similar, comber is used, but the mechanisms are different. So, this mechanics we will discuss here. First, let us discuss the basic idea of combing process. So, we can see in the left side, this is the ring bobbin, and in this ring bobbin the fibers, the short fibers are protruding from the surface, that means yarn surface. If we see the yarn, the short fibers are protruding here. So, this basically it is due to the short fiber present in the mixing, and if we remove the short fiber we get very clean, and the hairiness is reduced and yarn is relatively clean and it becomes little bit lustrous, that I will discuss why, and yarn strength also to some extent increases. So, this is the combing machine, and you see this is carded yarn, and after removal of short fiber, if the short fibers are eliminated, the yarn structure become like this. Okay. Now, the combing operation is used to enable the ultimate yarn to be smoother. So, yarns become smooth. Why? Because the short fibers are not basically hold in the yarn structure, they try to come out from the structure and forms hairs, and this hairs actually makes the yarn rough, and at the same time the short fiber present in the mixing, it forms the floating fibers in subsequent drafting, maybe in ring frame or in roving frame, and which forms irregularity. So, yarn irregularity also increases if we use the carded sliver. So, after combing the yarns become smooth and we can use higher draft for same cotton fiber as the number of short fibers are removed. The most of the fibers present are longer. So, the inter-fiber cohesion increases. So, inter-fiber cohesion increases. So, in that case we can have less number of fibers in the yarn cross section. So, yarn cross section as the less number of fibers are there. So, for same fiber we can produce finer yarn. So, if we compare with the carded fiber and combed fiber, so from the same fiber we can produce finer yarn. Next is the stronger yarn. As we can see in carded, when we are using carded fiber, the fibers are distributed. So, long fiber and short fibers are there. Okay. So, here the contact area is reduced, okay. Contact area is lower per number of disconnect. So, if we can assume that this is one disconnect, but contact area is area of overlap. So, total contact area by number of disconnect is much lower than in case of combed fiber. So, in combed fiber the short fibers are removed. So, total contact area per disconnect will be higher. So, the yarn becomes stronger. For same fiber, if we keep the twist same, so we can have higher stronger yarn, okay. Yarn strength becomes higher. Next is improved appearance. So, yarn appearance will improve because of the removal of short fibers and yarns that some even if some small quantity of trace particles are there, they are removed. So, yarn becomes much more cleaner, more uniform, because the fiber length distribution becomes better, because short fibers will result the more and more floating fibers and the yarn uniformity improves after the combing. It becomes cleaner as I have mentioned, and we get softer yarn. So, the reason being that, so for we get stronger yarn due to more and more overlap. Now, here one thing we can do, we can reduce the twist to get equivalent strength. So, we can reduce the twist for combed sliver. To produce combed yarn, we can reduce the twist. So, if we reduce the twist, say this is the carded yarn, and for combed yarn for same yarn count we can reduce the twist. If we reduce the twist, then what happened? The yarn becomes softer and finally, the fabric is softer. So, that is why we will see for expensive high quality product or innerwear we use the combed cotton yarn. And also you can see here the cleaner and improved appearance. So, one additional thing happens when we reduce twist, the this combed yarn actually reflects the light uniformly. So, it becomes lustrous. So, appearance of combed yarn is much better than the carded yarn. Carded yarn becomes little bit dull due to higher twist, where the light gets refracted, okay, at different direction. So, removal of short fibers, this is the basic objectives. First objective is the removal of short fibers, and short fiber we remove with a predetermined quantity. So, we can set the how much do we want to remove. So, accordingly we remove. Suppose let us see, this is the cotton fiber shorter diagram. Okay. Here is the fiber length, here is the proportion of fiber. Okay. Now, if we want to remove say 15%, so this is the total area, total mass. So, 15% of that. So, what is the length? Suppose this is the 15% of the total. So, this predetermined mass we can remove. So, we will set our machine which is the, so that this the any length less than, so this is the length, any length less than L can be removed. Then next objective is that to remove the impurity, whatever impurity is left in the draw frame sliver, that can be removed, eliminated from the sliver, from this fiber. Removal of naps and slabs. So, during combing, when it is processed through the comb pins, to removing the naps and slabs, that it is possible. Straightening and parallelization of the long fibers which are retained. So, fiber parallelization and straightening takes place. So, fiber sometime comes in the bulk form, buckled form. So, this buckling can be straightened out. Formation of sliver having maximum possible evenness. So, these are the basic objectives of the comber, but main objective, this main objective of comber is the elimination of short fiber. Okay. So, the elimination of short fiber improves the staple length, also affects the fineness of raw material, that we will discuss. So, removal of short fiber is the prime objective, and whatever we are getting, that is impurity, naps, slabs removal, straightening of fibers, we automatically get this, all these objectives. And here when we see that we remove the short fiber, it improves the staple length, and staple length of the fiber increases because short fibers are removed, but at the same time it also affects the fineness of raw material. Now, if we see here for cotton, cotton being a natural fiber. So, within a ball, suppose within a cotton ball, this is the cotton seed, here the fibers will be there, this is one fiber, another fiber is a short fiber. So, long fiber. So, as the fibers length increases during the growth, okay, this is a long fiber, during the growth the fiber length increases, these are the matured fibers, fully matured, length is high, but at the same time the fineness, these fibers will be little bit thicker fibers, and that means these are the coarser fiber and longer fiber, and the short fibers which are removed, immature fiber sometime. So, these fibers are short fibers. It is not necessarily it is always there true, because during the carding and blow room operation the fibers can also break, but generally it has been observed the short fibers are finer in nature. Now, during combing, when we remove all the short fibers, that means effectively the long fibers are there and effective fineness of the material increases to some extent, but that increase is insignificant. So, that is why we do not take into consideration. Now, there are different types of combers. One is rectilinear comber, which is very popular in cotton industry and woolen industry. That means fiber movements are in linear direction from back side to forward side. Circular combing is also used mainly for very delicate fiber, extra long fiber. Rotary combing also used, and hackling. Hackling is used for extra long staple fiber, extra long fiber, that is mainly for flax industry. Hackling is used, jute and flax industry, where the fiber length can be as high as 1 meter. So, that here it is a short fibers or fiber parallelization takes place in hackling machine. So, we will be discussing here only the rectilinear comber. The short staple spinning mill uses only the rectilinear comber, and the single sided machine and double sided machines are available, and single sided machines are generally almost all the manufacturers they produce 8 head. That means 8 the laps, comber lap, feed laps are used at the back side, and there will be 8 different combing heads, and finally it produce. So, a single delivery or double delivery sliver, and double sided machines are also used. It was initially tried to have double delivery machine, 6 feed heads are 6 heads are there in each side, but the main problem is not that popular due to the problem of maintenance. So, if in case of any breakage anything happens, so the main working head comes into the center. So, that is the problem. Now, there are basic elements. Let us discuss basic elements of short staple comber. The elements are divided into different zones. So, one is feeding element, then nipper element, nipping element, then combing element, then detaching element. So, feeding element function is to feed the comber lap to the main machine, and nipper element there are couple double pair of plates which grips the feed material, so that proper combing takes place. So, after nipping only the combing elements come into picture. So, it has got 2 section, one is cylinder combing, another is the top combing. So, that we will be discussing here, and detaching. After combing, the fringe has to be taken out to form the sliver. So, that detaching element does this function. Now, let us see first the feeding element. So, this is the cross section of combing machine. Now, here the feeding element consists of of feed plate and feed roller. This is the feed roller and its a feed plate is there, and to feed the comber lap in a series of short length. So, that is very important. The feeding does not take place continuously, it takes place in a small step, short step. Okay. So, intermittent feeding is there, and nipper plates, this is the top nipper, here is the bottom nipper. Nipper plates, the function of nipper plate is to grip the fiber, to hold it, so that the cylinder comb does not take the fiber as a club. So, it helps in combing. So, to comb the fiber, one end has to be gripped. So, the gripping action is done by the nipper plate. The short fibers, naps and truss being removed. Here is the cross section. Now, you can see the combing section. Now, combing section consists of two combs, as I have mentioned. One is cylinder comb, bottom. So, the combing section is actually pins are fitted on the a cylinder. It is not to the entire surface, some portion of the surface is filled with the pins, rest become smooth. That helps in the other different process like your top combing, nipping. So, this process we need the space. So, it consists of two combs, one is rotating bottom comb and linear top comb. Linear top comb is just like our hair comb, the very fine pins are there on a bar. The circular comb performs the main combing action. So, it combs the front or leading end of the fiber fringe, that is a main combing action takes place, and top comb completes the function of the bottom comb, which combs the trailing part during the detachment process. During, say, these are the detaching roller, this is detaching roller, and detaching roller during its forward movement, it takes away the combed zone, combed fringe, which is combed by the bottom comb or cylinder comb, and then the top comb comes into picture. So, this is the top comb comes into picture, and when the material is being pulled, it pulls through the pins of the top comb. So, that means, let me draw, this is a detaching roller, okay, and here we have top comb. Top comb. Now, the fibers, these are the fibers. This leading part is combed by the cylinder comb. Now, the trailing part of the fringe is being combed by the top comb during the forward movement of the fibers, when fibers are actually pulled by the detaching roller, and during that time whatever short fibers are present at the trailing side, trailing end, this will be restricted. It will not be actually removed, it will be restricted, and here we have the actual lap, comber lap is here, and at the leading part the short fibers, whatever naps are there, impurities will be accumulated here. So, now let us see how is it look like. Okay. When the detaching completes, these are the laps, this is lap, and here there are short fibers which are being restricted by the top comb here, and along with that if few foreign particle, dust, trash are present, they are present at the leading end of this lap. Now, in the next cycle when cylinder comb will act, this is a cylinder comb will act. So, cylinder comb will take away all these short fibers, in the next cycle, and this short fibers are short fiber and trash particles at the leading part of the lap is actually removed at the previous cycle. So, this will be taken away and removed by the brush roller. So, in this way majority, as we have seen, majority of the function is actually done by the circular comb, okay, main function. Top comb only restrict the movement of the short, actually it separates out the short fiber from the trailing part of the fringe. Now, detaching roller, there are two pairs of roller which grips the fringe. The rate it rotates, actually the rate of forward movement and backward movements are different. It rotates both in forward direction and backward direction intermittently to hold and move the combed wave for a net forward movement. So, it moves forward, then backward and then forward. So, this forward movement is suppose x and backward movement is say y. So, y will be less than x. So, there will be net forward movement. So, this complex movement is actually done using the epicyclic gear. So, this epicyclic gear mechanism we will discuss later. So, this mechanics is very important, how the epicyclic or differential gear is acting on the combed fringe. So, these detaching rollers are driven by the epicyclic gear. This we will discuss later. Now, the combing sequence we have to discuss, we have to understand the combing sequence now. So, this animation, let us see this animation. Here we will see that how the detaching roller are moving or to and fro, okay, and this feed roller and nipper reassembly moves forward and gets opened up, and when they are coming backward they will be closing. So, their opening and closing takes place, and when this at the backward portion, this nippers at the backward portion, they are being combed. So, and now let us see the animation for the combing section. Now, we can see here that here we have the lap and lap roller is there, and then this green color, these are the nippers, top nipper and bottom nipper, and here you have the cylinder comb and in this side these are the pair of detaching roller. Now, we will discuss the motion. This is continuing. Now, try to see the nippers are coming backward and it is closing down and closes, and when nippers are closing, the material whatever projected material are being combed by the cylinder comb. Okay. This is now going back once again, the nippers are coming back, it is backward feed and feeding is taking place at this time, feeding has taken place and then nipper close. As soon as nipper closes, the cylinder comb is combing the leading portion of the fringe, okay, and the whatever noils were there, the short fibers are being brushed by the brush roller is shown in the red color. Now, this is now leading portion is being combed by the cylinder comb. Now, it is moving towards the detaching roller. Detaching roller, the overlapping is taking place. Now, when the needle cylinder nippers are now again close. Now, we will see that when nippers will start moving forward direction, it is and then the detaching roller rolled backward direction and overlapping took place, and that time when detaching takes place, the top comb which was shown in the blue color. Now, let us see once again. Now, during detaching action, the top comb comes into picture, and during the forward motion of the detaching roller, top comb will comb the trailing portion of the fringe. In this way, the combing takes place. So, leading portion we can see of the fringe is combed by the cylinder comb, and then overlapping takes place, and during the overlap, after overlapping, the detaching roller starts moving forward direction again, and that time the trailing portion is combed by the top comb which is shown in the blue color. It is coming now, blue colored top comb has come into picture. Now, this process continues, okay, and this is the process. Now, we will try to understand the other aspects. Okay. So, combing sequence, it starts with the feed roller, feeding. So, feeding we have the feed roller, and here there are two nippers NB and NT. NB is the bottom nipper, NT is the top nipper, feed roller F. Now, feed roller F moves the lap sheet L, this is the lap sheet, in the forward direction. The nippers are held open because during feeding the nippers will be opened, otherwise the feeding will not take place. And second sequence is nipping. In during the nipping, the top nipper comes downward and it closes the nip distance. So, this is top nipper comes down. So, it nippers are closed. So, upper nipper plate NT lowers on the cushion plate, that is bottom nipper, fibers are clamped. So, fibers must be clamped just before the cylinder combing, otherwise the fibers will be taken as a clamp. Then rotary combing, the cylinder combing segment that there is a segment as I told. So, the total surface is not filled with the or covered with the pin section, that combing section K mounted on the cylinder comb, and this combs the fiber fringe which is projected. So, B is the fiber fringe projected, and that portion will be combed, and during this combing, suppose this is the top nipper, here is the bottom nipper, and this is the fiber fringe, this is the B fiber fringe. Here whatever short fibers or the trace particle present here gets removed. Here the top nipper NT and bottom nipper NB, they are holding the fibers, and whatever the short fibers and trace particles or naps present in this zone, the projected zone B is being removed by the cylinder comb. These are whichever are not held by the nipper, but the fibers which are held by the nipper will not be removed, they will be simply combed, which is our basic objective. Now, the nippers forward. So, these nippers become close when the nipper is at the backward most point. So, what nipper does? Nipper moves forward and backward, okay? And during forward movement nipper gets opened up also. During the forward movement nipper gets opened, and during the backward movement nipper closes. So, at the backmost point nipper is closed, so that the cylinder comb comes into action and combing takes place. Now, at this point what happened? When nipper comes forward, so the top nipper moves upward and nippers open, and it allows the fiber overlap. So, then detaching roller starts moving backward. So, this whatever fiber fringe previously combed fiber fringe was there, they are overlapped with the newly combed fiber fringe. So, nipper open again, moves towards the detaching roller D. Now, wave return is by the detaching roller. So, detaching roller starts moving backward, roller returns, the part of the previously drawn wave, that is V, returns back, and then piecing. What is piecing? Piecing is the overlapping and joining of the web. So, at the piecing section what happened at this stage, what happened during the forward movement of the nippers forward movement, the projected fibers, the projected fiber fringe B, this is the projected fiber fringe B after the cylinder combing is placed over the previously combed fringe V, which has been returned by the detaching roller. They are overlapped, they are placed on that, and in this way joining takes place, and then the nipper will continue moving forward. By that time the detaching roller starts coiling or forward movement. So, this joined overlapped fringe is coming under the action of the nip of the detaching roller, and this combed fringe, newly combed fringe will be detached from the remaining remaining lap, and during that time the top combing takes place. Okay. So, and where no upward and downward movement of the top comb. So, top comb is present somewhere here, and there will be no upward and downward movement. Top comb is fitted on the nipper assembly, it moves only forward and backward direction, but due to the setting of nipper point and the feed plate or feed roller or nipper setting. So, this the fringe, newly combed fringe will be pulled through the top comb. Penetration is due to detaching. So, detaching setting is little bit higher, it will be pulled through the top comb. Now, the detaching roller rotates forward direction, draw the fibers out of the sheet, this lap sheet, okay, held fast by the feed roller. So, the fiber lap will be gripped by the feed roller. At this point feed roller does not rotate, so does not fit. So, this will be pulled and the fringe will be teared apart from that sheet, and it will be through the top comb. So, that the fiber does not come in the clump form, and the whatever short fibers were there, they will be short fiber naps at the tip of the lap, that they will be retained. So, now combing by top comb, this section top comb has come into the action. Before the start of the detaching, top comb comes into action. Single row of needle penetrates into the fiber fringe. Normally it is not by the up and down movement of the top comb. In old slow speed comb, this type of motion was there, but now at high speed combing they do not move, there is no up and down movement, and trailing part of the fringe, that is the W, that is the fringe, trailing part is combed by the top comb. No upward up and down movement is there of the top comb. Penetration is due to the detaching. Now, return of the nipper assembly once again. So, nipper assembly returns back, and during the return movement the nipper, top nipper moves downward, and again it is ready for the next cycle. So, nipper assembly returns, nippers open for next feed. So, during return movement there may be the next feed if it is the backward feed. So, there are two types of feed. The feed roller rotates momentarily. If the feed roller rotates momentarily during the return movement of the nipper assembly, that means when nipper moves forward, say it is moving forward direction, it is opening up, and when it is moving backward, it is closing up. In this way nipper assembly works, and during the backward movement of the nipper assembly, if the feed takes place, then we call it as backward feed, and during the forward movement of nipper assembly, if the feeding takes place, it is a forward feeding. So, both the feeding are available. We can set forward feeding or backward feeding, depends on the requirement, and it has got impact on Noel percent, that we will discuss with the Noel theory. So, nippers open for the next feed. Top comb withdraws. So, top comb is can move out, move up. So, that is not available for modern high speed comber that I have discussed, and this up and down movement of the nipper is available for wool combing, because the thickness there, the thickness of the sheet is very high. So, in that the proper penetration is required, and now it is ready for next cycle of combing. So, again next cycle will start, like it starts with the feeding, and it starts with the cylinder combing. And last part is that this cylinder comb is actually filled with the short fibers, naps, whatever materials were been removed from this web, that has to be cleaned. So, this is the brass is there which cleans the cylinder comb by the stripping action, and so that for the next cycle the clean wear points are presented. So, combing cylinder rotates and the brass roller strips of the short fibers from the combing segment, and the total steps from 1 to 10 we have discussed. This whole steps are known as the combing cycle. Now, this is one single combing cycle. Now, in a high speed, in a modern comber, this cycle is actually typically 450 to 500 cycle. Now, it becomes 600, 700 cycles per minute. So, in 1 minute if you see 600 cycles are there. So, that we can imagine, say for particular for a per second it will be approximately 10 such cycles will complete. So, it is very high precision required. Now, if we see the diagram, say all these motions are to be linked. So, starting from the feeding to the detaching, so every process has to be linked. So, here we can see this is the diagram of movement, and if we actually there is a index wheel is there. In the index wheel through this diagram we can see how all these motions are interlinked. In the index wheel there is a 40 say index points are there, index number. So, 1 is the first index number, it is actually superimposed with 40 number. Now, in that case if you see the cylinder comb action, now cylinder comb action will be there when there is a nippers are closed. So, cylinder comb action you can see here. So, cylinder comb action is from 1 to say up to 4 point. This is the cylinder comb action here, and in the other side you can see that may be 36 to say 40. So, that at that zone cylinder comb is under the action. That means, when cylinder combing takes place, what are the things? Things are nippers should be closed, then only cylinder combing should take place, should be working. Otherwise, if the cylinder is open, then the combing will not take place. So, nippers are closed up to point 11, that is index number 11, and from 11 the nippers starts opening. That means, when nippers are moving forward it is closed and then it starts opening. So, it opens and it remains, it is open, and maximum opening it's at between 23 to 25 point. So, it is actually it goes like this, it opens, maximum opening is there, and after that it starts going backward and it closes. So, nipper here it is showing nipper forward, and between 23 to 25 it is moving forwardmost point. At the forwardmost point nipper opening is maximum, and then nipper starts backward movement, and during backward movement up to say 33 point nipper is closed, and then during the in the closed condition nipper continues moving backward, okay. And when it is closed around say 36 point, the cylinder combing starts. Now, in case of backward feed, during the backward movement momentarily there will be rotation of the feed roller. So, at the backward movement, so backward motion starts say at 25, between 23 to 25 it starts. So, backward feed, the feed roller will start rotating between 27 to 31. So, during that time feed roller will feed the material. Similarly, for forward feed that means when the nippers move forward and nippers are open. So, there should be two conditions here. In the backward feed the two conditions are there, where that means nippers should be opened and nippers are moving backward direction. Similarly, in forward moving nippers are opened or opening during that time and nippers are moving forward direction. So, between 13 to 22 the feeding takes place, and if we see the detaching roller movement, detaching roller will start rotating backward, return will be starting at 0.7, it goes up to 0.18. So, it has fed back. By that time when detaching roller is returning the material, and by that time the nippers moving forward, nipper plates so detaching roller feeds the material backward and nippers are moving forward. So, the nippers moving forward, detaching roller returns, okay. And that time the piecing takes place, and then detaching roller moving advanced, okay. It will moving forward direction, return, then forward direction, and again another movement, it is a normal advance. So, there are three types of motion. One is called return motion, fast return, fast advance, then normal advance. This normal advance is just to feed that this will result the actual delivery of the material. Now, hook removals take place in combing, which is very important function along with the short fiber removal, and it is important to have even number of process between card and comber in cotton combing. So, here we should have a even number of processing. This is a card and comber, in between there should be even number processing. So, why? Each process means you have reversal of the hooks. So, if we see the in general the trailing hooks are maximum in card sliver. So, although we have discussed it depends on the doffer speed and different parameters, but in general it is a higher in size number. So, we can say trailing hook is a major hook. So, our target should be to remove the trailing hooks in the comber. Now, this is the carding machine. Carding produce the trailing hook, major hooks, which is shown by the this direction of the hook. Now, this is the card can. Now, in the draw frame, in the drawing, what happened? This can, from this can, the sliver comes on the from the other side, which has entered at the later time will be removed first. So, it is fed in the leading hook direction, and here the lap formation zone, it is actually, this is the lap formation. Here it is the coming in the leading hook direction, then it is coming the trailing hook, and in the comber it becomes the leading hook. Now, here we can see this is one operation and in the second operation. So, in the lap formation, the second operation. So, this even number of process means even number of reversal, which results in the during the combing we are feeding the material in the leading hook direction. In the card we assume that it is producing in the trailing hook direction. Here majority of hooks will be in the leading hook direction, and what the advantage we get during the cylinder combing, these leading hooks are preferentially be removed and we will get the maximum fiber extent. But in wool combing this is reversed, that I will discuss. So, if we use odd number process, what will happen? The lap, the comber lap will feed the lap where majority of fibers will be in the trailing hook direction. In that case, what will happen? The fiber extent will remain smaller. So, this may go in as a waste, but in the even number of cycle, the short fiber, that is the hooked portion, will be removed and fiber extent will increase. So, this will not go in the waste. In case of wool comber, so long staple comber, the feeding will be reverse, there odd number of process is used. So, first let us see the wool combing process. Now, feed of sliver. So, here lap formation is not there. In wool combing the slivers are bulky. So, lap formation is not there, directly we use the sliver. So, odd number of processes are there in between the carding and combing. So, typically 3 draw frame stage is given. So, odd number. So, majority of hooks in is at in trailing direction in case of cotton comber. So, in cotton combing it is we are feeding in the leading direction, that I have mentioned. So, leading hook will get removed, but in the long fiber, in case of long staple spinning, to minimize the fiber breakage and noil extraction, we use the odd number of process. where we use the fibers in trailing hook direction. So, we can see here. So, this is odd number process, first gill box, second gill stage and third gill stage. So, where due to the odd number of process, the slivers or the feed material with higher number of trailing hooks are being fed, and this will result lower fiber break, meaning it minimize lower fiber breakage, because in case of wool long fiber, the fibers are very long, and these hooks are not just like a cotton fiber hooks, the hooks will be acting as a loop, and if the nipping is taking place, these are the nipper plates, if this is nipped. So, here this loop will be there, and then cylinder comb will come into picture, and this will break the this loop and make a one long fiber will be made two short fibers. So, fiber breakage will take place. Now, let us see the wool combing process. So, here we are not going to discuss the details of the process. First, only thing we will discuss what are the difference from the short staple cotton combing, because the mechanisms are same, the steps are same, here feeding, nipping, cylinder combing, everything will be there, but just the difference is that just to accommodate the long fiber, the wool fibers are very long and the bulky. So, that we have to do here, we feed in the form of series of slivers. Now, these are this feed roller, this is feed roller, A is a feed roller, B is a feed grill. So, this is the short staple cotton combing, this one is wool combing. Feed gill and upper nipper, this is upper nipper, and here this is lower nipper, and here we can see that R is feed grid. So, we have feed gill, that one surface with the pins, and feed